So when we were getting, when we're finding the solutions or the zeros, and we use the quadratic formula, and we get a negative under the radical, we would just stop and say no real solutions. Really, that's the correct term, is no real solutions, because there are non-real solutions. Okay, we call those complex roots. So the complex roots are the roots that have I in the answer. Okay, so this one here, this little mean. So imaginary is telling pi to be rational, because pi is an irrational number, because it's a decimal that goes on forever and doesn't repeat. There's no pattern. And then pi is looking at the number I and saying get real, because I stands for imaginary. It's an imaginary number. So it's supposed to be kind of funny, but whatever. But these notes are posted. So if you guys want to take the notes that way, you can. Otherwise, it would just be good with a piece of paper just to write down an example or two. Okay, so if you guys remember, you guys saw this in Algebra 2, but a complex number is written with two parts. So you have the real part, and then plus or minus the imaginary part. Okay, and in standard form, it's the real plus or minus imaginary. But sometimes, if the real part is a negative, they'll switch it around. Okay, so A is the real part, and then B is the imaginary part. It's nice and easy. So like if you had 2 plus 4i, that is one complex number. Even though it has two parts, it's actually one complex number. So the real part is 2, and the imaginary part is 4i. Okay, so complex numbers, so when we get solutions, we can't graph those solutions on a normal X, Y, or Cartesian plane. It's called a Cartesian plane. But there is a complex plane that looks like this. So notice how the x-axis is now labeled as the real axis, and the y-axis is now labeled as the imaginary axis. Okay, so let's say we wanted to graph these. Let's say these were our solutions that we got, our non-real or our complex solutions. Well, we'd have to go to the complex plane and graph them there. So 3 minus 2i, well, you graph the real part and then the imaginary part. So I'm going to go 3 units in the real direction, and then I'm going to go negative 2 units in the imaginary direction. So that's going to be 2 down, which is going to be down there. So this point represents that one number. So because there's 2 parts, you go in it looks like there's an X and a Y, but really it's one number. So like negative 4 plus I. So I'm going to go back 1, 2, 3, 4. And then I'm going to go up 1 in the imaginary direction. Okay, so what about this one? How would we graph that? Just negative 3i. How could we graph that?
Down 3.
Just down 3. Because really there's a hidden 0 there. So that was just down 3. That would be negative 3i. So graphing the complex numbers and the introduction of the complex plane, are you guys okay with that?
Yeah.
Okay. So normally I'd have you guys talking with each other on this, but say we had this point right there. That point is on the complex plane. Okay, think about what the complex number would be that represents that point. Okay, so John, what would be the complex number that represents that point? Johnny Dora.
Hang on, what? What was the question?
What would be the complex number that represents that point?
It would be 2 minus 3i.
There you go. 2 minus 3i. Next one. Think about this one for a second.
Or is that wrong?
No, you got it. It's right here. The answer it just came up. So look at this next point. Okay. Leonardo, what's this one going to be? That point right there. What complex number represents that one? Leonardo?
Is it -2?
So just -2 would be right there.
Well, I mean -3i.
So -3i would be right here.
Is it -3 plus I?
-3 plus I would be right there.
So -3 plus 4i?
-3 plus 1, 2, 3, 4 would be right there.
-3 plus 5i.
There you go. -3 plus 5i. Thanks, you. Okay, next one. Say it's just right here. Think about what that would be. Okay, Caitlin, what would that be right there? What would be the number that represents that point?
Would it be 2i?
Yep, 2i. And then last one right here. Okay, Gabriella, what's that one going to be?
-5.
Yeah, just -5. So that one's actually a real number because there's no imaginary part. So that would be a real number. Okay, so now the imaginary unit, if you're going to write something down, you should write this down. So I equals the square root of -1. So basically, when you have a square root with a negative in it, okay, if you have a square root with a negative in it, you can take the negative out and it becomes an I, the imaginary unit. Okay, so I know it says -1, but just think of it as there's a negative there. You know what I mean? So even if you wanted to kind of just go shh. Okay, so here's what I'm talking about. So let's say we have the square root of -3. Well, the square root of 3 is irrational. You can't go any further. You can't reduce it or anything. But that negative we can reduce now. Because really -3 is -1 times 3. And so the square root of -1, that comes out as I. So right now I put the I in front, but really, just like any variables, you want to have your number in front and then the variable behind it. And the reason why I had it in front first is I wanted you to see that it's outside of the radical. Because if I just went straight to this answer, a lot of you are still going to put that radical sign over the I. Don't extend that radical over the I because it doesn't go over it. Okay? So when you have a negative, the I actually comes out of the radical, comes out of the square root. Okay? Let's say we had square root of -25. Anyone want to guess what the square root of -25 would be?
5i?
Excuse me. Yeah, that's right. So I take the I out, but remember it's really behind it, but I'm just showing you right now that it's outside, but you'll always see the I's coming to this side. And so it really becomes 5i, because if it was I5, then we're talking about the iPhone 5, right? But think about this one. It's a kind of funny meme. Get it? Get it? Oh, how cute. He has an imaginary friend. It's just it's cute. Okay. So this whole imaginary unit is going to come up. It's going to come up right here. So when we're using the quadratic formula, what we care about is inside the radical. So like b squared minus 4ac. So let's say I had this, okay, but there's other stuff around it. But I'm not worried about that. We're just focusing on the radical. So we have 16 minus 24. Well, you're taking away 24 away from 16. So there's more. You're going to have a negative number. So you end up with negative 8. Okay, but you can reduce this now. We can reduce at least the negative, but square root of 8 can reduce too. Let me see if I show the work on that. So the I comes out, and then remember square root of 8. Square root of 8 is really like the square root of 4 times 2, but the 4 comes out as this 2. That's what that 2 came from. So my answer is 2 radical 2i. You always want to put the I on the other side of the number. Okay, so the radical doesn't extend over the I. So normally this would be a U try. Okay, if you guys got a piece of paper and a pencil, take about 2 minutes and see if you can do that problem. See if you can reduce it.
Mr. Sexton,
Yeah.
sorry about before. My Wi-Fi was like really bad, so I disconnected.
I don't know. I don't even know what you're apologizing for, really.
I just felt bad for not answering.
Oh, did I call you? I didn't know I did.
Yeah, you did earlier.
Huh. All right. So let's see. Let's go down here. And let's go with, I don't know who I've called on yet. So Stephen, what'd you get for this one?
I'm still trying to solve it right now.
Oh, still trying to solve it. All right. So you picked up a paper and pencil and you've actually wrote something down?
I mean,
Not really.
no, regular. I mean, I'm trying to do it in my head.
Mm,
-4? Well,
close, but you
4?
still got to go further.
Is it 2 squared I
2 squared I?
or rooted? Sorry. I think.
No. Let's see, Jesus?
Isn't it the same answer as the last one?
No. Not the same as the last one. Shelly, what do you got? Shelly. Mm-hmm.
Is it 2i?
Yeah, so Jesus got it here. I guess you guys don't see it though. Yeah, it would be 2i because you're right. It is. Sorry. So it's 4 minus 8, which is square root of negative 4. And then remember the negative comes out as I, and then square root of 4 is 2. So it's going to be 2i. Okay? So you guys got to be able to do that. You got to be able to reduce those because that's just a small part of the whole puzzle.
Mr. Sexton, what about the plus or minus? Does
That's
it matter?
a good question. Remember, if we had the quadratic formula, there would already be a plus or minus in front of these. But this, the way it is presented is an expression, remember? And expressions, when you take the square root, you don't have to worry about plus or minus. It's when you're solving something and you take a square root in order to eliminate like a square. So to solve for x, that's when you have to include the plus or minus. Okay, so here you wouldn't, but it is part of the quadratic formula, so you would have a plus or minus in front of it anyway, so you don't have to worry about that. Cool, you gave me a little bass. All right, so
Sounded like a microwave.
that's all right. So if you're gonna write anything down, go ahead and write this down. Because this is a good example that includes that type of answer. Okay, so we got to start being careful now, and we got to pay attention to our answers because we're not always going to have rational or irrational roots. Okay, we can now have complex roots. So if we try to X factor, that should be actually our first step, is to try to X factor, but it's not going to work. Let me see if it. So first thing we should have done is try to X factor. A times C is 2 and B is 2, and we need two numbers that multiply to 2 and add to 2. What are two numbers that multiply to 2 and add to 2? There aren't any. Okay, so then we would go to the quadratic formula. Now remember, if X factor doesn't work, like in this circumstance, the nothing matched for 2 and 2, then your roots are either going to be irrational, meaning you're going to have a square root in it, which is quadratic formula, or they're going to be complex. They're going to have an I in it. So it could be one or the other. Okay, so we're using the quadratic formula here. And this is actually the square root that I just had you guys do, right? Because it's 4 minus 8. And then 4 minus 8 is negative 4. And what did we say that was, the square root of negative 4?
Two.
Not just 2.
2i.
2i. That's right. So that's going to be 2i. And you guys, I just graded. You guys had a worksheet that was like one problem. It was like one homework assignment, like one problem for the assignment. And I went through, and a lot of you were leaving your answers like this. And I said you got to split them. And some of you even reduced just with the front numbers. So remember, you got to reduce with all 3 or none. Okay, so you can reduce now if you want it. And then you end up with negative 1 plus or minus 1i over 1. Now there's some ones that we don't need there, and there's actually one of those ones that has to be there. So basically, which is the one that has to be there?
Negative 1.
The negative one, exactly. Thank you, Ida. So this negative one is the only one that has to be there because 1 times I, well, that's just I. And if you divide something by 1, well, it doesn't change that number. So that is simplified, but remember, I want them split. So you've got negative 1 plus I and negative 1 minus I, but if we're doing it in set notation, we want the negative or the minus I first. Okay, and who's to say which one's, bigger or smaller because we're dealing with complex numbers here, complex roots. Okay, any questions on that particular problem? Okay. Anyone still need this up? Okay. Oh, and it says to graph the roots too. So we're going to graph them on, what's this called again? Do you guys remember what kind of plane this is?
Complex.
The complex plane. It's a complex coordinate plane. So we would do -1 minus I and -1 plus I. So they'll always be, across from each other on the real axis. Because of the plus or minus. And why did the mathematical tree fall over? Because it had no real root. All right. So I want you guys to take a little bit of time and I want you to do this one. All right. So Jesus provided an answer. You guys see it? What do you think?
I got the same one.
You got the same one? Okay, so that's. Let's go through it. So I got my A, my B, and my C. Okay, so this is 100 minus 120. Not that big of a deal, easy to do. So you get -20. So think of 20 by itself without the negative, and then just put an I on the outside. So what are the numbers I'm gonna use when I think of 20 if I want to reduce a radical?
4 and 5?
4 and 5, and why 4 and 5? Why not 10 and 2?
4 is a perfect square.
4 is a perfect square. Thank you. So this is actually 4 times 5, and then you could take the square root of 4 out. Okay, so the I comes out, and then that's 2 rad 5. Okay, now really what I would do, and it's probably going to be different on my presentation, but we should split it right now. So we've got negative 10 over 2 plus or minus 2 rad 5 over 2, and then we have an I over here, right? And then these reduce. Negative 2 or negative 10 divided by 2 is negative 5. And then these reduce to 1, and we get rad 5i. And now notice, this is already in standard form because we got the real part and we've got the imaginary part. So that's why splitting it, that's what I want. When I say split, that's really what I'm talking about. So when I sent back those worksheets, that's what I was talking about. So let me erase that, and I'll show you guys the other way too. So we can reduce here. We can reduce because 2 and negative 10 both have a common divisor of 2. And then remember, when you multiply 1 by something, you don't need it. And when you divide something by 1, you don't need it. So we end up with negative 5 minus rad 5i and negative 5 plus rad 5i. So Jesus, is that what you had? I don't remember. Yes? Oh, now we got a graph. So rad 5 is around 2.23. So, I mean, we're not going to be perfect, but we'll guesstimate where it needs to be. So negative 1, 2, 3, 4, 5. And then plus 1, 2.23, like right about there. And then negative 5, and then minus 1, 2.23, right about there. Okay, any questions on that? So why would this be a mathematical insult?
Because he's calling him 4i.
4i, because square root of negative 16 is 4i. And then guys, I'm letting you have this one, right? As a pickup line, it's yours. Telling you can use it.
Thank you.
Okay. Anytime you want, don't even worry about it. Because if she really doesn't understand what it means, then she's not worth your time anyways. Okay? All right. So let's stop share.